Now, I love playing with sensors, and recently I've been looking for something that can measure particulate matter. So I came across this Air One sensor from Apollo. This one can read a whole range of particulate matter sizes, and it also does gases. So let's have a look-see. So Apollo Automation is a small company started out of Kentucky manufacturing sensors. Now, having a look at what they've got a millimeter wave sensor, an air quality sensor, and a garage parking assistant. So today we're going to have a look at this one, the air quality sensor. Now, this is a sensor that offers millimeter wave, PM1, 2.5, 4, and 10, as well as volatile organic compounds. And it also offers us the option of CO2 if you add that on as a sensor, and also with the gas sensor. So the one I've got. So having a look at the casing, you'll see it's a nicely 3D printed case, and we've got these 3 screws holding it all together. Now on the sides we have 3 ventilation sides plus ventilation in the top, and as with properly made PM sensors, they have a little fan that actually draws the air through to measure the particulate within here. So it also has its power supply on the side here. That's your USB-C, and the moment we plug that in, you'll see that the LED will start flashing, telling us it's busy, ready for connection to the Wi-Fi network. So all we need to do now that it's powered on, open up the Wi-Fi on your phone, search for the Apollo access point, select your Wi-Fi name and put the password in, and then it will connect. So now we can just go along to settings, devices and services, and there it is. So we'll go configure and we will submit, and there we go, it's created it. We can select an area. I'm going to say I'll put this in my kitchen and finish. So here we go. Now we can go along to ESP Home. There we go. We can look for our Apollo Air. There we go. All right. So having a look at what we've got here, the beauty about this system is that it is all ESP Home, all local control. So having a look at the controls we've got here, we've got a calibration. So the beauty about this is you can take the sensor outside here, press the button, and it will then calibrate it down to 400 parts per million. It also has a clean button. So what this will do is ramp up that little fan inside there and basically clean the filter. You also have an RGB light that you can switch on, and we can control that. So this is pretty cool. We can select different colors based on, for example, different results on our sensors. Having a look at the sensors here, we've got our different gases. We've got CO2. As you can see, the CO2 is working really well. It was at around 400, well, just under 400. It's because I hadn't calibrated it, but seeing as I'm working here, it's pushed right up and getting up towards the 1000 parts per million. We've also got all these other gases like ethanol, hydrogen, methane, nitrogen dioxide, etc. Then we've got our PM sensors. So as you can see, these are giving us readings, and you can see there's a couple of peaks there, and I'm going to show you just now how those react to various stimuli. Now, humidity and temperature, these are directly affected by the temperature created by the ESP32. However, they do give you a little offset here. So I've already set that up. I've got an 8 degrees offset and a 20 degree offset here for the, or 20 point offset for the humidity. So that works okay, but honestly, I would be using external sensors for temperature and humidity. We also have this button. We can change that as a startup blinking LED. Down the bottom here, we've got some diagnostics. This is quite cool. It tells us the temperature that the ESP is operating, our signal strength, etc. All right. So what I'm going to do first of all is I'm going to show you this PM. Now, one of the ways I was told you can test for particulate matter is to take the sensor reasonably close to your head and rub your hair so that you've got some dandruff floating out there, and we should see a little bit of a boost, and there we go. You can see there immediate response, and we've got a bit of a boost in our particulate matter there. Now I can go and clean the sensor by pressing that. So there we go. The fan's going to clean it out, and you'll see that that will pull those little tiny flakes out of there. Now, the next thing I tried is basically I wanted to see what some of the gases are doing. So what I did first of all was I got a match, and I lit a match in reasonably close vicinity to the sensor just to get an idea of what this will do. And you'll see immediately that our particulate matter goes crazy because we've got those little pieces of particulate that are flying away from the actual burning. The other things that have gone up, we've got our volatile organic compounds. Those have come up a little bit. So yeah, that is definitely working. The other thing, there we go, our volatile organic compounds gone up. Now, the next test I did, and this is quite interesting. Unfortunately, I didn't have anything to test these all these different gases, but what I did try, which was quite interesting. Now, don't spray too close to the sensor or you might damage it, but I've got an aerosol deodorant can here, and I'm going to spray it reasonably close to the sensor, and what you're going to see is how crazy these are going to go based on this aerosol. Look at that, methane is just shot up, our carbon monoxide, ammonia, look at all these things just shooting way up based on that. So all in all, I'm very impressed with this little sensor. It seems to be operating. I can't really test the accuracy in any way without getting other sensors, but overall, super impressed, very easy to use, and I would recommend this sensor to anyone that wants to get a handle on their air quality within their home. That's all for me. Have a great week. Bye for now.